In this video, we'll look at graphs and tables of exponential functions in order to explore the properties of these functions. We'll be using the Desmos graphing calculator. An exponential function can be written as an equation, or it can also be shown in a table. In this video, we will be exploring exponential functions of the form f of x equals a times 2 to the x. Let's use the Desmos graphing calculator to do this. Start by creating a Desmos window. You may want to log in. Input the function f of x equals 2 to the x as shown. F of x equals 2 to the x. This is the graph of an exponential function with a base of 2. You can also create a table of values for this exponential function. Click on the plus sign and look for the table icon and click on it. Follow these steps. Click on plus, then click on table. By default, you'll see x1 and y1, but we want to link this table to the function we just created. Replace x1 and y1 with x and f of x as shown here. x1 becomes x, y1 becomes f of x. Now input values for x in the table, starting from 0 to 3 in equal increments, like this. 0, 1, 2, 3. You'll see that the program automatically calculates the values for f of x, along with the graph of these points. Notice how the points are not equally spaced. As x increases by 1, y doubles in value, which makes sense since the base is 2. And you can see on the graph that the points are not equally spaced. This is one of the properties of nonlinear functions. As x increases in value, f of x changes at a faster rate. Now let's add a coefficient to the exponential term to see what happens. Input the function g of x equals a times f of x. G of x equals a times f of x. You'll be asked if you want to create a slider for a. You do, so click on the blue button. By default, the value of a is 1, so the graph of g of x overlaps the graph of f of x. But before changing the value of a, go to the table to add a column for g of x. Click on the table and then click on the column to the right of f of x and enter g of x. You'll see the output values for g of x. Now increase the value of a to 2. Now you can see the two graphs. What do you notice? In the table, you see that the values of g of x are double those of f of x. In the graph, you can see that g of x has the same shape, but its corresponding points are higher. In other words, a higher value for the coefficient a results in a higher rate of increase. You can see the increase in the table of values and in the graph. Now change the value of a so that it is 1/2. So change the slider to 0.5. You'll see that the graph of g of x dips below the graph of f of x. But what does this mean? Look at the table. You'll see that the output values are decreased by half. When a equals 0.5, the rate of increase for g of x is less than that of f of x. Now change the value of a to a negative value. So let's change it to -1. As you can see, a negative value for a changes the orientation of the graph. Look at the table of values. And you can see that as x increases in value, g of x decreases. So a negative value of a changes an increasing exponential function to a decreasing exponential function. In general, the coefficient of the exponential terms in an exponential function affects the rate of change and whether the function is increasing or decreasing.